Hello, Honors Higher Algebra students. This is Mr. Johnson, and this is the fourth lesson in Unit 16, which we're studying statistics. And in this particular lesson, we're looking at the inverse normal. And so the idea here is kind of the opposite of what we did in the last lesson. So in the last lesson, we were looking at this idea of this bell curve. Well, that's really bad, I'm sorry. So we have this bell curve like this, and we had the mean or the average, and we knew that there would be one standard deviation, two standard deviations, and three, and one on the other side, and two on the other side, and three on the other side. And we knew certain aspects of this particular bell curve. So for instance, we know that this represents 68% of the data, and we know that this represents 95% of the data, and we know that this represents 99.7% of the data. And again, those are estimates that we ask you to memorize. And we found out that with the norm option of the calculator, we were able to calculate certain elements. Let's say, we wanted to figure out what's going on with this this data point. Maybe let me do more accurate, like maybe a range like this. We're saying, okay, what percentage of the total fits in that category? Well, it doesn't fit the traditional ones that we had you memorize. And so therefore we used our calculator to say, okay, what if we wanted to figure out between here and here, what percentage of the student population fits into that category based on whatever we're studying, okay? So what we're going to do now is kind of flip the tables a little bit. Instead of looking at this range, let's say this was a test and you say, okay, how many people scored between 70% and 92%? Instead of doing that, we're going to ask the question, what would you need to score in order to score at 95%, 95 percentile, or in other words, to be in the top 5% of the class? So we're kind of flipping the scenario and asking those types of questions. So let's say that we wanted to, figure out, instead of being given this little red range like this, we were asking the question, I want this to be my goal for the test, and that is to be in the top 15% of the class scores, that type of thing. Okay, let's go on to the next page. So this inverse normal is kind of an abstract idea, but it's also very useful. Many of you took or have taken tests when you were younger, oftentimes in elementary school, and you're put on paths because of that, educational paths because of that. So for instance, you're probably on a math path, or this particular math path, because you scored in some sort of percentile in elementary or middle school that pushed you into a certain path of math. And all of that percentile talk, the 99th percentile, or even my own children, as they were born and we bring them into their 6-month-old appointment or their 1 or 2 year appointments, that kind of thing, the doctor always says, well, their height is in the X percentile, that kind of thing. My daughter has always been in the very low percentile because she's really tiny, and my sons have been in a larger percentile because they're a little bit bigger. And so those kind of percentiles are what we're going to be studying here. So here's an example, not very practical probably, but that's okay. So it says consider population of crabs where the length of the shell, X, is normally distributed. That means it's a bell curve, okay, with an average or a mean of 70 and a standard deviation of 10. Biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. So you have your bell curve like this, okay? And if we want to kind of just think about what's going on here, let's just say that this is 5%, which means that this is 95%, right? And so only the top 5% will be harvested. Well, when you think about this, we don't have that data memorized, because when we look at our standard deviations, we don't have a category that allows us to identify exactly 5% on the upper end. We have, we have some specific percentages, but we don't have 5%. That's not one of the normal ones that we have memorized. And so we're going to need something a little more abstract. Okay, so then the question is, okay, 95% of the crabs have lengths less than what? So what is this magic length of crabs right here that basically designates 95% of the crabs right here with the 5% right there that can be harvested. And so we're trying to ask this question: what is the probability, or what is the value of k such that that is the case? And this is the idea, or the need for the inverse normal function. Okay, so let's take a look at our bell curve here. And again, these are the values that we've memorized. Keep in mind that this is one standard deviation right here away from the middle, two standard deviations, three, and then on the same on the other side. So we have fuel consumption of a Boeing 747 in cruising mode averages 3,213 gallons per hour. Assume that the consumption is normally distributed, so that means it's on this bell curve, with a standard deviation of 180 gallons per hour. A 747 is in cruising mode needs to be repaired if it is in the top 2.5% of consumption rates. What is the maximum rate for this 747 to not need repairing? Okay, so this one actually is one that we have memorized, because when you think about it, we have our 95% of the data between two standard deviations from the normal, from the middle. And so therefore, by deduction, this little bit here, and this, I mislabeled that, hold on, the rest of it here and the rest of it there must add up to the remaining 5%, because you need 100% represented. So if 95% is between the blue right here and right here, well then the rest of your data, which is the red, so it goes in either direction, off to the left, off to the right, must be a total of 5%. So this must total up 5%, okay? And so therefore, this must be 2.5%, and this must be 2.5%. And so what we're looking for specifically is the top 2.5%. We're looking at this little magic number right there. So we can actually do this without really any major calculator use. If we put in some data here, let me actually erase some of this. Okay, and let's go ahead and put in some of our information. So the middle here is 3,213, and we're looking at a standard deviation of 180. So I'm just going to use my calculator and add 180. That gives me 3,393. I'm going to add 180 again. That gives me 3,573. Remember, our magic number is this bit right here, because that's going to represent 2.5%, or the top, I should say, 2.5%. And so therefore, what is the maximum rate to not need repairing? Well, essentially this value right here, 3,573, will be sort of that magic number. Anything beyond that would be in the top 2.5%. And so our answer will be certainly that. Anything less than that should be okay, but that's sort of the the value in which we need to have the 747 repaired. Now you could argue that it must be less than that, and that'd be fine with me, because I suppose you could say that at that moment that's kind of in need of repair, but anything above that is in the 2.5%, or the top 2.5%. Okay, so many times it's not that easy where you're taking the standard normal distribution breakdown, and so we need to use the calculator to do this. And so you can see some of the keystrokes here. I'll be walking through them. I'll also have some resources in Schoology for that. So here's our example for a population with a mean 23.6 and a standard deviation of 3.1. We want to find the value that has 95% of the data below it. Okay, now you got to be really careful with this, because we do have memorized the 95%. Now keep in mind that 95% is from, so here's our median right here, or sorry, our mean, and then here's one standard deviation and two, and here's one standard deviation and two. So technically there's this section right here that is 95%. You got to be really careful though, because that's not what it's asking. It's saying 95% of the data below it. So what that means is that if we go back, let me just kind of get rid of all this stuff. So there's this kind of magic, there's this magic value right here for which this is 5%, and all of that is 95%. and we don't have that one memorized. So that doesn't fit into either the 68 that we memorized, the 95 that we memorized, or the 99.7 that we memorized. And so therefore we need this value, and that's going to be sort of a question mark, but our calculator, of course, can do this for us. So what you're going to do is you're going to type second and the DISTR button. You can see that right here. That's the distribute button, or the distribution button. And you're going to go to option 3. It's called inverse or INV norm. So that's inverse normal. That's what we're studying. So hit enter. You will see something like this. And many of you will also see this option that says tail, left, center, or right. If you see that, you should pretty much choose left for everything. Essentially, what that's describing is that whatever you put in here is representing the value in which you're analyzing to the left of it. So if we put in, and go ahead and type in 0.95, what we're saying is that if we type in the area 0.95, we're describing the area to the left of 0.95. So in other words, we want to find the value that has 95% of the data below it. So when we choose left, that means that 0.95 would describe things to the left of it. So just kind of keep a standard option of left, because that's how we're going to think about this. But this is obviously left of the value we're identifying. That's why we're choosing or selecting left. Okay, for the mean, we have 23.6, and for the standard deviation, we have 3.1. Then you go down to paste, and paste will just simply put it into your main calculator screen, and you hit enter. And when you hit enter, when I hit enter there, I got the value of 28.699. It does go on, but that's an easy spot to round to because the next digit was 0. And so what does this mean? Well, find the value that has 95% of the data below it. Well, the value would be 28.699. Okay, let's look at sort of a different angle at this, and that would be how about the value that has 10% of the data above it? So let's draw a bell curve, same kind of general data here, except we're looking for this magic value right here that has 10% of the data above it. Now, if you look back on the previous problem, that said 95% of the data below it, which meant that 5% of the data was above it. So you can see that every problem could be asked kind of two different ways here. So in this problem, it says 10% of the data above it. Well, what that means is that 90% of the data is below it. So if we were to fill this out, what I would do is put in 0.9. That would represent 90, because I always think of it as the left of it. So I would say 0.9 because that's 90%. Then we would have our same average, which is 23.6, and our same standard deviation of 3.1. I'm still choosing left. Now, again, you could absolutely choose right, but then you would have to change your area to be 0.1 because then it's describing to the right. I just kind of keep it the same because for my brain it's just a little bit simpler, I guess. So we have all of our values in. I'm still choosing left, and I hit enter. I'm going to get 27.52, and then it's 27.57, and then it's 28. So I'll just round that to 3 to make it 3 decimal places. Okay, and again, if you wanted to go back and check and put in 0.1 for the area, and then make the option to the right side, we should get exactly the same thing. Okay, and I just did on my calculator, it worked. So again, it's important to understand that when you choose your area right here, and you choose, let's say, left, you're describing to the left of the value you just analyzed. That's what it's going to give you versus to the right. Okay, all right, let's try another problem. Okay, a university professor determines that 80% of this year's history candidates should pass the final exam. The exam results were approximately normally distributed with a mean of 62 and a standard deviation of 12. Find the lowest score necessary to pass the exam. So this is actually this is actually something that does occur or has definitely occurred in the past quite often, and that is that professors would determine, or teachers in general would determine, all right, I want to have X amount of students pass. And so they would have all of their data, all of their scores for their test, would range a great deal. They say, okay, who cares really what everyone got in a sense? We want to make sure that 80% pass. And so they put it on a curve and they take a look at the normal distribution and all of the stuff that we're now studying. So in other words, they have this known value right here of 62. That's your mean. And the standard deviation is 12. So we could kind of piece this out. But the key here is that the professor wants to find this magic value right here. Oops, that's a question mark. So wants to find this magic value for which 80% of the data is above it, because he wants to make sure that 80% of the candidates pass the final exams. The question is, what is the lowest score that ensures that you pass? And remember, by default, this is 20% because it has to equal 100%. So again, you could do this a couple different ways, but the way I'm going to do it is sort of the way that I've been modeling all along, is that I'm going to type in, I'm going to go into my inverse normal, and I'm going to type in the area as 0.2. Because remember, that's to the left. I'm just going to keep the left kind of as a standard here. And then we have our average, which is 62. We have our standard deviation, which is 12. Again, I'm choosing left. You're welcome to choose right if you want. And so I get from this 51.905. So if we were to round to 3, it would give us this. And actually, let's make sure we kind of think about this. So this, is our exact value we get from the calculator. We don't quite know if on this particular test you could, who knows exactly what the 62 represents, or if maybe, I don't know, a half point is possible. But certainly, I think a 0.901 is probably pretty rare, or not possible. So we're guessing. Let's just guess whole numbers here. If you were to stay with 51, then you're not, you're sort of to the left of this question mark, right? And if you had 52, you would be to the right of it. And obviously, it looks like we're rounding here. But what I'm trying to say is that our score would really need to be better safe than sorry. So we would say 52 or higher means that we would pass the exam. Okay, we have one last example. So the lengths of fish species are normally distributed with a mean of 35 and a standard deviation of 8. The fisheries department has decided that the smallest 10% of the fish are not to be harvested. What is the size of the smallest fish that can be harvested? Okay, so we're dealing with our little bell curve like this. Okay, our average is 35, standard deviation of 8. And we're concerned with this magic little number here, whatever that value is, that gives us the smallest 10%. Okay, so the smallest 10% are not to be harvested. Obviously, all of this is 90%. Okay, and so we're trying to figure out what that magic number is. So we're going to go to our inverse normal. We will type in for the area 0.1. We have our average, which is 35. We have our standard deviation, which is 8. And I am doing this from the left again because 0.1 would be representative of 10%, where that's to the left. And so we have, let's see, 0.1 and 35 and 8. And I get 24.74, and I'm just gonna, that's 7.5, so I'm gonna round to 8. And so again, I'm assuming maybe that they're just gonna measure the fish by the whole centimeter. Okay, so here what we would say is what is the size of the smallest fish that can be harvested? Then we would say, okay, that's got to be 25 centimeters. And I know it looks like, again, we're rounding that, but just you would want to make sure that you were on this side, right, of the appropriate measurement for harvesting the fish versus the left side of that. Okay, so that's it for inverse normal. Thank you.